Yeah, let me share my screen. So, sorry for the delay. And what I want to ask you is, am I audible? Hello? Yes. Okay. Fine. What I want to ask you is, have you understood SP hybridization process? Last time we had discussed, कळली तुम्हाला hybridization process. Any difficulties need to be repeated or something? Actually, that is right now not included, but whatever you have understood, shall we go further? Okay. So we were talking about intermediate species. Okay. Now, intermediate species means what happens in a reaction. So when you're talking about anything which happens, say for example, A plus B giving you C plus D. Say this is a substrate, this is the reagent. That is methane is the substrate, A reagent. Sorry, methane is a substrate. Another reagent is B, that is chlorine. When reacted, what you get is a product and a byproduct. As I said last time, that bond breaking and bond formation takes place. It is a multi-step. This is only a one-step reaction. You can have multi-step reactions also. Now, during that time, what happens? So, first thing is bond breaking process. Then could be bond breaking and bond formation. So, there are different types of bond breaking processes happening. Last time, is homolytic and heterolytic fission clear to you? There needs to be told anything with respect to the homolytic fission and heterolytic fission. Did we talk about that? It is a fish hook arrow, then wherever the two products which are getting formed, say for example, if it is homolysis, then you get free radicals. And if it is heterolysis, then the bond breaking takes place in such a with this that you get the cations and the anions. One moment, let me see. What do you say? What's happening with respect to this attendant? Heterolytic we haven't done. Homolytic. Okay, let me start from directly. I will again do the homolysis, and then we'll go back to heterolysis. Okay, fine. So let me just see. Another thing is, please talk to me if you don't follow or don't write on because it takes a long time for me to come back and then just when I'm on the screen with respect to when I'm teaching you, then I can't see. So तुम्हाला काही difficulty वगैरे असेल तर please unmute करा आणि बोला कारण हे मला त्रासदायक होतं म्हणजे लाईक इथे मागे येऊन बघून मग पुन्हा तिकडे जायला इट इज अ प्रोसेस. सो what I suggest you is that yeah. So now coming back to this and let me take out my open board. Today my computer is also creating some problem. Yeah. Now what happened to this? Yeah. So now there are different types of covalent bond, the types of cleavage in a covalent bond. Cleavage means breaking of the covalent bond. why is this? Okay. So here there are different types of cleavage in a covalent bond. First, just homolytic cleavage. That day we saw that. Let me just revise this. Say for example, this is the molecule. I'm just taking this chlorine as the molecule. You know that two chlorine atoms are connected to each other by a bond. That is mutual sharing of electrons. So here there is one electron, other electron over here. Now when this breaks, it undergoes homolysis. Homolysis means, look at the arrow which I'm putting in, and it is called as a curved arrow, and it is called as a single barbed arrow. Curved arrow, or this arrow is curved arrow, but it is a fish hook arrow. Fish hook arrow. Why? Because it is like माशाचा जसा गळ आपण टाकतो ना तसं त्याला हे असतं असं this part. So it is a fish and it is a curved arrow, and it is also called as single barbed. That is, it has only one side, so it is called as single barbed arrow. BARBED, single barbed arrow. Now when this breaks, what happens is that each atom gets one electron each. So here you can see that these are the two elements which get one electron each. That is equal chain. Now you can see there is no charge. I have not put any charge. It is a neutral species. Okay, so equal sharing of electron, that is the bond breaks such that each one of them gets now this happens when both these atoms have same electronegativities, because otherwise if the electronegativity difference is there, then one of the group then goes away with a pair of electron. That will be talking about in heterolysis. ओके, त्यामुळे इलेक्ट्रोनिगेटिव्हिटी त्यांच्या इक्वल हव्या तरच तुम्हाला हे टाईपचं होमोलिटिक फिशन मिळू शकतं. किंवा when you are carrying out this reaction in presence of sunlight or light because there are photolytic reaction. Photo म्हणजे light and lysis means breaking. So photolysis or photolytic reaction. So that is called as photochemistry. Photochemistry gives rise to these free radical type of reaction. बऱ्याचशा reaction photochemistryच्या या free radical reaction असतात. So let us listen. A covalent bond can undergo cleavage or fission in two ways: homolytic cleavage and heterolytic. A covalent bond comprises of two electrons, that is a bond pair shared between the two bonds. That is a homolytic cleavage of covalent bond in that is, as I said, that the covalent bond is made up of two electrons which are shared equally. In homolytic cleavage, what happens is one of the two electrons goes to one of the bonded atoms and the other is bonded to another. Other is bound to another. So it is an equal sharing of that electron. That is, no element takes the pair of electron. It breaks to give that each one gets one electron each. Now, moment of single electron is represented by half-headed curve arrow. This is it, half-headed or single barbed arrow. The tail, this is the tail of the curved arrow, indicates the place from where the electron is removed, while the head tells you where the place where the electron reaches. So you can say that this is the tail and this is the head. So tail of the tells you from where the electrons are coming, and the head tells you where the electrons are reaching or what is the final destination of the electron. Such homolytic cleavage of covalent bond give rise to two neutral species carrying one unpaired electron each. These species are called as free radicals, or sometimes they are also known as radicals. Now, these species, a radical is never ever stable. It is unstable. It is highly unstable. In fact, it will revert back. This if it does not find any thing to react with, immediately it is a reversible reaction. That is, it will go back again to A and B, because see, each one of them have one electron. It cannot stay like this for a longer time. So therefore, it goes back to its original this. Unless if you have some other this component, it will react. For example, this is another example which is given, that is methyl free radical, and you get the chlorine free radical. So here you are. Homolytic fission is favored in presence of, as I said you, that ultraviolet radiation, or it is in presence of photolysis, that is photolytic cleavage, or sometimes peroxides. Peroxides are chemicals which gives rise to, they have, see, whenever the oxygen is more than the regular this, then it is called as peroxides. That is more of oxygen is there in that, rather than, now say for example H2O is water, but H2O2 is hydrogen peroxide, H2O2. So that is, it is more than the regular amount of oxygen which is there. So it is peroxide, more this. Those are used for oxidation reactions, or they give rise to these kind of free radicals reactions. The organic reactions which proceed by homolytic fission are known as free radical or non-polar reaction. Free radicals have only transitory reaction existence. That is, they exist for a very short time. Okay, they are formed as reaction intermediate which subsequently react with other radical or molecule. Now coming to the shape, this last time I concentrated, or I donated some time of my lecture for explaining you what is hybridization and what type of hybridization. So in this case, a carbon free radical is sp2 hybridized. So in this case, this carbon is sp2 hybridized and has a planar trigonal geometry. We have seen what type of hybridization, that is one s orbital and two p orbital, they mix together to form these three equal energy orbitals. So these are the sp2, and the remaining vacant p orbital is there, that is capable of carrying that one electron. So that one electron normally resides into this. Say for example, the shape of CH3 is like this. In this case, this is that CH3, and this electron would be whatever that arrow has been shown over here, that is that single electron in the unhybridized p orbital. So the shape of this is sp2 hybridized, and the bond angle, if you have to check it out, it is how much, that is not between this, sorry, these sp2, like this and this. Okay, it is 120 degrees because it is planar trigonal, 120 degrees. Whenever it is, if you remember sp3 hybridization, then it is 109.5 degrees. When it is sp hybridization, it is linear geometry. When it is sp3 hybridization, it is tetrahedral geometry. Okay, so that way you have to remember. If you remember last time, if you have any difficulty, we can discuss that again later on. But now now these free radicals have a, they are they can be classified into, that is where this is the carbon atom which is now carrying the electron, that free electron. So here it depends upon, alkyl free radical are classified as primary. This is the primary, this is the secondary, and this is the tertiary, and this is the methyl free radical. So now if you have to look at these structures, which is more stable, then you will understand this is more stable, then this is less stable, this is still less stable, and this is the least stable amongst all of them. So highest stability is with respect to the tertiary free radical. So that way, that is how you have to remember. So your chapter, I mean, this part comprises of, that is when you talk of homolytic cleavage, first you will have to define what is homolytic cleavage. That is a rupture of the single bond is in such a way that the bond is broken, and the species which are formed, they carry a 1 electron each. These species are highly unstable, and it is represented by a single barbed arrow or half-headed curved or fish hook arrow, as they say. Okay, and this happens in presence of light energy or peroxides. Then what is the shape? Then so you have to explain first the formation. Second, you have to talk about the shape. The shape of free radical is sp2 hybridization is involved over there, and it has planar trigonal geometry. And then which amongst these are more stable? Then you can tell that tertiary butyl free radical is the most stable, followed by isopropyl, that is tertiary, secondary, primary, and methyl free radical. Is it clear so far? Shall I go further now? Have you understood? Fine. So others, Samir and Suraj, are you there with me? Are you there with us? Because only Sankalpa is answering, others are not answering. Suraj has just said yes. Suraj and Samir. Okay, fine. So now let us go to the next. That is, okay, Samir is also there. Now let us go to our next part, that is heterolytic cleavage. Now in heterolytic cleavage, a covalent bond shared, that is covalent bond shared electrons go to one of the two bonded atoms. That is now either, like here how we did was we splitted them equally. You know, the bond was cut into two this so that each one gets one electron. Now in this case, look at the this turns out to be more electronegative atom of the now whichever is the more electronegative element, the electron pair goes to that. Now I'm using the term pair, not single electron. So and it is represented by a curved arrow, but now to look at, see the head of the arrow. This is directly how we write, that is a double barbed arrow. Heterolytic cleavage of covalent gives rise to, and it gives rise to two charged species. This arrow is normal arrow, and but it still has a tail and a head, and head will indicate the position of the electrons to which element those electrons are going. Okay, it gives rise to two charged species, one with a negative charge and other with a positive charge. The negatively charged anionic species has more electropositive atom, and the negatively charged anionic species is a more electronegative atom which has taken away the electron pair or the shared electron. The heterolytic cleavage is represented. Anyways, I want to explain this. So what happens is, say for example, this is it. Let me explain it here, then I can read it. Don't. Okay, here. Now amongst these two, you can see that chlorine is more electronegative. Okay, now here what happens is this, the pair of electron, this is the pair of electron. Now you show it with double barbed arrow or normal arrow, wherein you show both the sides of the arrow. So here you show it. And now you can see that these electron pair is shifted directly towards the more electronegative element. Now more electronegative element gets the electron pair, then naturally the other group which is there, it does not, I mean the electron pair has left it, so now it gets a positive charge. Whereas here you can see that chlorine gets the negative charge because now it has got the electron pair which was there bonded, so it's extra electron, so therefore that can be shown with a negative charge. This is called as one, this is the carbocation which is formed, carbocation, and this is the anion which is formed, that is chloride anion which is formed. That is, now you can see the charged species are formed. Whereas when we are talking about homolysis, what was seen over here, that you can see that we did not show any charge, therefore we just put it like this. These were the neutral species, whereas this is, so these are favored by non-polar, this is a non-polar reaction, this is a polar reaction. So this takes place mostly in the gaseous phase. This can take place in during your normal, that is your, when you carry out the reaction in a solvent, this can, polar solvents will favor this kind of a reaction. Okay, let me go back to that. So here what happens is that moment of an electron pair is represented by the curved arrow. So this is the curved arrow. Heterolytic cleavage of a covalent bond gives rise to two charged species. We saw those charged species just now, one with negative charge and the other with positive charge. The negatively charged anionic species has more electronegative atoms. So there it was chloride ion which is more electronegative, and it takes away the electron pair. A heterolytic cleavages represent. This is the general representation of heterolytic, wherein you can see that there is a cation and there is an anion. Now in this case, B, because it is an anion, B is more electronegative. ज्याच्याकडे electron pair जाते तो जास्त इलेक्ट्रोनेगेटिव्ह आहे, म्हणून तो इट कॅन होल्ड अ इलेक्ट्रॉन पेअर. ती जी इलेक्ट्रॉन पेअर आहे ते प्रोपोजर का असे, फॉर एक्झाम्पल लेट मी गो बॅक ओव्हर हिअर, असं कधीच होत नाही, म्हणजे रेअरली होतं, म्हणजे But this is because carbon and hydrogen will not be able to this carry this negative charge for a longer time. Okay, but in chlorine, yes, it can hold it for a longer time. It will move away with the electron pair. This is possible. This is possible in some other cases. We can talk about that later on. But here, this is very rare kind of a reaction happening. Okay, now coming to say for example, look at this. This is an example which is given. I use chlorine over there. They have used bromine. It is methyl carbocation and bromide ion. Bromine is more electronegative than carbon, and therefore it can hold that electron pair properly. Now heterolysis is favored in, that is, this reaction happens in polar solvents, as I told you. That is, that reaction was happening mostly in presence of light or gaseous phases in methyl bromide, but this happens in polar solvents. In methyl bromide, bromine is more electronegative. Thus, heterolysis of methyl bromide results in the formation of, you get a carbocation, that is a methyl carbocation and bromide ion. Now, here you can see that the shape of the molecule changes. Now you can see a carbon atom having sextet of electrons and a positive charge is known as carbocation. Okay, so now here, see, initially when it was, this was there, this molecule, see, it was tetrahedral molecule. There was sp3 hybridization. But the moment bromine goes away, then now you can see that the carbocations are highly unstable and reactive species as intermediate, and they have sextet of electrons, that is, they have got only 6 electrons and a positive charge. How come it is possible? Why they are having only 6 electrons? So you can see that now here you can see that this is 1, 2, 3 and Cl. Here you had how many electrons? You can see 1, 2, 3, 4, 5, 6, 7, 8. Now, when this heterolysis happens, see, you can see, show that, then what is your product which is formed? CH3 and plus Cl minus. So now you can see that those 2 electrons which were over here gone here, and here you have now vacant orbitals. So this carbon has 3 sigma bonds. These are the 3 sigma bonds, and it has a vacant orbital, say any, because now the electrons are not with it. The electrons have gone with chlorine. So this is again the shape which is also sp2 hybridized shape. This is sp2 hybridized. Because this is one sp2, you get 3 equal energy orbitals in sp2 hybridization. So this is another sp2 hybridized orbital. This is another sp2 hybridized. But here, then the remaining p orbital, which is not hybridized, remains over here, which is empty. Now it does not have any electron. But if you remember, in free radicals, you had a similar shape, but that time there was a single electron in it. So shape depends upon, now in case of free radicals also, you have this kind of a shape, whereas here when the orbital is empty also, you can have sp2 hybridization. Okay, so remember that. Am I clear so far? Are you people following? Or am I going little faster? कळतंय का तुम्हाला? Hello? Sameer, it is clear. What about Sankalpa? Is he there? Fine. Okay. Now coming to yeah, so here you can see that the central carbon atom, so this is the central carbon atom of a carbocation is sp2 hybridized and has trigonal planar geometry. So this has having a trigonal planar geometry, same as sp2, bond angle will be 120. The pz atomic orbital is vacant and is perpendicular. That will be perpendicular to the plane containing the 3 sigma bonds. So if you consider this as slicing the screen, म्हणजे या screen ला cut करून जात असेल, this is supposing this whole structure is in the plane which is slicing the screen. म्हणजे तुमच्या जो मोबाईलचं स्क्रीन आहे त्याला असं स्लाइस करून गेलं, कट केलं आपण सरळ, आणि मग त्याच्यामध्ये बघितलं तर you will get this p orbital as perpendicular to that, वरती आणि खालती it will be the p orbital. I hope so. This is how it is going to be perpendicular to the plane containing the 3 sigma bond. These 3 sigma bonds are in one plane. And now you know this, that the thick arrow tells you that it is coming towards me. The wedge arrow, that is the dotted line, tells you that it is going towards you, and this is in the plane. Okay. So this is about the shape of carbocation when there is heterolysis. So now the next is, so we talked about how they are formed. How they are formed when there is one element which is more electronegative than the other. Heterolysis is unequal distribution of the electron pair. That is the electron pair which is actually shared in a bond is unequally distributed during the fission. That is, the more electronegative element carries the electron pair and then it goes away in the reaction, but then the carbon is left without the electron pair and it is called as carbocation. This is called as heterolysis. It is represented by it is a curved arrow, and the arrow shows the what do you say, the its head shows the electrons where they are going, and the tail shows from where the electrons are coming. The direction is represented by that curved arrow. When the curved arrow is normal curve, that is double barbed arrow, it is not single barbed arrow, it is not fishhook arrow. So this is about the shape, and then the shape, because they can ask you a full mark 2 or 3 marks question. Explain what is heterolysis, what is the shape of the carbocation which is formed. Then the carbocation will have sp2 hybridization, and wherein the p orbital is vacant. In free radical also you have similar hybridization, but that p orbital carries one electron in it. It is a neutral species. Now come to the next part, that is stability. When you talk about such species, you always have to, so the question always will be based on how it is formed, what is the shape, and what is the stability. So remember all that in the exam. This can be asked as discuss the shape of it, or how it is formed, or what is heterolysis. And now we come to the stability. So let us talk about stability. Carbocations are classified again here. The carbocations also, when they are formed, anything related to carbon, you can see that whenever it is again primary, secondary and tertiary. The observed stability of alkyl carbocation is, again you can see that the tertiary carbocation is more stable then the secondary. The secondary is more stable than the primary, and primary more stable than the methyl carbocation. Just like your free radical, even they also have this kind of stability, that is tertiary more stable than. Now consider a case which is exactly opposite. Now let us see, let us say that, say for a, sorry. Say for example, no, I can't use this. Ideally, you cannot have electronegative element over here, and then that can, I cannot show an ulta effect. But supposing I have this ulta effect, in such a case where what happens is that this breaks, okay, you have some reagent, and I'm just using hydrogen because it is less electronegative than carbon. So then what happens, you can see that in this case, you will get such an reaction wherein now carbon is keeping the electron pair, whereas hydrogen is without the electron pair, hydrogen is gone. So you can see, look at the movement of the curved arrow, it is towards the carbon. Ideally, I should not be showing it over hydrogen, I should be showing it where it is going. Technically, nobody is going to give you wrong over here, but when you're showing it, show it properly, it should be on the carbon. Okay, so here you are. So now that carbon is carrying negative charge. Now it has got extra electron. Now therefore it is negative. Now you say that a carb anion is formed. First it was carbocation is formed, and now you have a carb anion which is formed. Okay, and so again here you have two charges. Again it is a polar reaction. It happens in polar solvent. Now let us see. So this talks about the formation of carbon ion. First one was formation of carbocation. So you have homolysis wherein equal sharing of electron pair takes place, and here the shape, this is free radicals are formed, free radicals. Then it is non-polar reaction, non-polar. sp2 hybridized shape. If somebody tells you to show the shape, you can show it like this with the p orbital. This is carrying one electron. Okay, this is not the electron, that is just a tipka which has come. Hasa stimba ala hai. It is not an electron or anything. चुकून झालं ते हां the electron is there in this orbital. ह्या orbital मध्ये मी हा electron show केलाय. Okay, so this is the free radical, non-polar and sp2 hybridized state. And here no charge, you can see that no charge species are formed. And stability wise, you can always say that tertiary, I'm putting in T, more stable than secondary, secondary more stable. You can show it like this also. Tertiary carbocation, it is degree sign. Secondary carbocation is, and then you have primary carbocation, that is 1 degree, and which is more stable than methyl. This was the revision of homolysis. Now again, what I want to talk about was heterolysis. Heterolysis, just now I did. In this heterolysis, you can see that again the formation, stability, structure and stability. In heterolysis, you have two types. One is formation of carbocation. Carbocation formation wherein carbon carries plus charge. So now here what happens is this is unequal distribution. It is a that was non-polar reaction. This is a polar reaction. And here you have charged species form. One is carbocation, which is, and the other is negatively charged. It happens because the element is electronegative, more electronegative than carbon, and it carries the electron pair towards itself. Here also the shape is sp2 hybridization. So if the shape is sp2 hybridization, but now here this orbital is empty. There is no electron in that. This, okay, and as I said, polar reaction, charged species are formed. Now in this case, exactly opposite stability wise, yes, again you can say that tertiary more stable, then secondary, secondary more stable, then primary, primary more stable, then methyl radical. This is the sequence of stability. Now let us see what happens about carb anion. Again same heterolysis, but in heterolysis now you have this carbon anion. Say for example here I can show that CH3Cl reaction or Br reaction, and this is going to carry the electron pair and you get carbocation. Now exactly opposite to this is you have some other group, and that other group, wrong, I should be showing it to the carbon. So here you are, and this carries the carb anion. So you get a carb anion. Now we have to see, look at the shape and then its stability. Okay, then the entire सगळं म्हणजे काय म्हणतात हिट्रोलिसिस अँड होमोलिसिस कम्प्लीट होतं ज्या वेळेला आपण ह्याचा पण शेप आणि वी डिस्कस अबाउट इट स्टेबिलिटी. सो हिअर यू कॅन सी दॅट द सेंट्रल कार्बन ॲटम of I'll take this. The central carbon atom of carbon has complete octet of electrons. So here now you can see, yes, octet of electron. How octet of electron? You can see that मगाशी जसं आपण बघितलं तर त्याच्याकडे किती, now this is one bonded to this hydrogen. Now I'm not showing hydrogen, I'm just showing two electron each. Understand that there is hydrogen over there. So or hydrogen or any other group over there. So here you have 1, 2, 3, 4, 5, 6, and this electron pair is being left by, there is no bond over here. So therefore this is negatively charged. You can count, these are 8 electrons. Whereas here you could see that there were only 1, 2, 3, 4, 5 and 6, and then you had a plus charge. Okay, so there is a complete octet of electrons and a negative charge. The carbon ion is unstable. Again, all these species are not at all stable. They are unstable and reactive which is formed as a reaction intermediate. So all these species are reaction intermediate. They are not existing in nature as such. They can exist in nature only when they are stabilized. म्हणजे त्यांना स्टेबिलाइज करायला काही चांगले ग्रुप्स असतील तरच ते असे राहू शकतात नेचर. अदरवाइज दे कॅन नॉट बी स्टेइंग दॅट लॉंग इन द I mean, they will not stay long with the charges on them. Even free radical, or they have to only if they are stabilized by strong groups, then only they can exist in nature. Otherwise, every species tries to be in a neutral state. So here you are, heterolytic fission is favored in polar solvent. We checked that आधी पण आपण बघितलं होतं ते. The organic reactions proceed via heterolytic fission are known as heteropolar, polar or ionic reactions. All these are because you know that ions are formed. So these are called as heteropolar, polar or ionic reaction. Very rarely you say heteropolar, you say polar reaction. Most organic reaction taking place in solutions follow ionic mechanism. Okay, so next is, what does it say? Some bond. Okay, let me just complete that and then we'll come. Okay, types of reagent. Achha, they have not talked about the shape of this. Okay, maybe that shape is not there for your syllabus. Actually, if you look at the shape is sp3 hybridization. Shape of methyl carbocation is there. Methyl carb anion is not there. Anyways, if it is not there, but still I would like to talk about the shape of that. Why it is given halfway? I don't understand. See, the shape of that will be, sp3 hybridized. Why sp3 hybridized? You can see that this is one sp3 hybrid orbital, this is another sp3 hybrid orbital, this is another sp3 hybrid orbital. So far we have talked about sp2 hybridization. Now this has sp3 hybridization, so that you can see that carbon is bonded to other hydrogen atom over here. This is a normal bonding, but this sp3 hybrid this sp3 hybrid orbital, which is now not vacant, but it carries this lone pair of electrons. So here it is this, and the shape ideally should be tetrahedral. Carbon should have any saturated carbon compound, that is like methane, should have tetrahedral shape, but this is not tetrahedral, it is pyramidal. Pyramidal means like pyramid. And on top of that, you have this orbital, which is the sp3 orbital carrying the electron pair. Okay, carrying the electron pair. So this is this shape is like a pyramid with your orbital carrying the electron pair, which is giving it a negative charge. This is the shape. Maybe it is a little difficult for you to understand, but I thought that let me explain you, since last time we did what is hybridization. Is it clear so far? Have you all understood? Are you following, or somewhere you need to? कळतंय का नक्की की उगाच आपलं हो हो म्हणताय तुम्ही? डोक्यावरनं जात नाहीये ना? I know organic chemistry is little. Okay, I hope I can. Sure, Sankalp and Samir, talk to me. Don't write just like that. Are you following?
Yes, ma'am.
Yes.
Sure. Hybridization was clear to you all.
Yes, ma'am.
Yes, ma'am.
Okay, I'm very happy. But if still you have any difficulty later on, let me know. Acha, coming to this, let us see what if you all have understood. So now you have understood it here so far. I mean, your syllabus restricts us over here. I would love to teach something more also over here. But halfway only they have left here. They have just explained the formation of carbon ion. Here they have just introduced the formation and the shape of the carbocation, just like free radical. But here they have not completed. I mean, maybe that is the case. So heterolysis is of two types. Homolysis, you get only one, that is the free radicals. In heterolysis, you get two, carbocations and carbon ions. Okay, carbocations, we saw the shape and stability. For carb anions, I think it is not there because I continued further, it was not there. Anyways, let us have a look at this. What it says that in this case, some bond fissions are described in the following table. For each of them, show the movement of electrons using a curved arrow notation. Okay, fine. Classify them as homolysis or heterolysis and identify the intermediate species produced as carbocation. Okay, fine. So yeah. So in the second case, what do you think? So what is it?
Homolysis.
Second case is homolysis. Very correct. Good. So since you have said is homolysis, here you are. This is breaking. This bond is breaking. One moment. This is becoming too thick. Yeah. This bond is splitting over. The color also is not good. Yeah. So here it is breaking. So I will put it half arrow over here and half arrow over here. Okay, and you are getting this free radical. So intermediate formation over here is free radical. Okay, intermediate is free radical. Let me reduce this. Okay, next, what do you feel? What is it? They have directly shown a reaction. So for you to understand that what happens in the reaction, so you can see that in this case, you are seeing an OH over here, which is the reagent which has come. Now what has happened?
Ma'am, is it heterolytic?
Yes, it is heterolytic because H is going away without the electron. Sorry, I've done Ulta. So now in this case, OH is taking away your this. So it should be, the arrow should be like this from this to this. So it is pulling away that, and when this is pulling away, the electron pair goes towards CH2. Okay, so this is how it is forming. So it is heterolysis, and the intermediate which is formed is carbocation or carbanion. What do you think this is?
Anion.
Anion. Very correct. Very correct. Now coming to this. This is simple. Tell me how. You don't answer, Sankalpa. Let Samir and Suraj, I don't know whether he's there or not, but whosoever is, acha, both of us are only there. Okay, fine. Then you only answer. Yeah. Can I, by the way, let me ask you, can I continue just 5-10 minutes little ahead because I started a little late today? Is it okay? Or you have any other class or something?
No, ma'am, no problem.
I can continue now. Yes. Acha, Sankalpa. But Samir is not there, na? He went. Okay, I thought. Fine. So now you tell me what happens over here.
Ma'am, heterolytic.
Very correct. Heterolytic. Arrow should be from here to here, right? There is no space, but arrow should be from here to here. Okay, so this is, you have positively charged carbocation. Sorry, carbocation. Now what about this? And what is the species also, you tell me, getting formed?
Ma'am, is it anion?
Yes, it is carbanion, and it is no, not carbanion. Sorry. Say again. What is it?
Cation, because positive, right?
Yeah. Even I also said this. This is negative, but cyno is negative. Here, this is you are having carbocation, and again homolysis or heterolysis.
Heterolysis.
Huh. Don't be so unsure. Directly say whenever you have homolysis, you will get this like this. You will get this. You won't get charge. Whenever it is charged, झोपेतनं उठून सांगितलं तरी म्हणायचं की charged species आहे, it will be heterolysis. If it is not charged, then it is homolysis. कळलं?
Oh, ma'am.
Fine. So here you complete types of reagent. Now let us understand what is meant by reagent. Identify the reagent, substrate, product, byproduct in the following reaction. So now, what do you understand by the term reagent? In this case, at least from your previous knowledge, can you tell me what is, which is the substrate, which is the reagent, which is the byproduct, which is the product?
CH3COCl is substrate.
Correct.
And H3 is reagent.
Okay.
CH3CONH2 is product and HCl is
Very-
byproduct.
byproduct. Very true. Very true. Okay. Now the polar organic reactions. Acha, by the way, tell me what, since we both are there, what is the status going on in your college about these chapters? How much have they gone further? What have they taught? Can you tell me?
Ma'am, actually in our college there are two teachers for chemistry. So
Okay.
one teacher is taking chemical equilibrium and the second teacher is taking organic chemistry.
So how far has he reached? How far has the organic teacher reached?
She's still in UPSC naming.
IUPAC name. Now,
IUPSC.
IUPAC name, he's doing it. But are you, since after joining here and we doing it, are you comfortable with what he's teaching, your understanding?
Yes, ma'am.
हे सोपं जात आहे ना तुला तिकडे?
हो हो.
हा बरं. आता मला एक सांगायचं आहे की बहुतेक मोस्ट प्रोबॅबली पुढच्या संडे पासनं कदाचित मी एखाद तास घेईन, कारण मला दुसरा चॅप्टर सुरू करायचा, कारण हा चॅप्टर संपत नाहीये. आयदर सॅटर्डे और संडे. सो वील टेल मॅडम टू कीप वन लेक्चर एक्स्ट्रा संडे किंवा सॅटर्डेला. तर तुम्हाला कुठचं योग्य म्हणजे वाटतं? आर यू रेडी फॉर इट? शॅल वी डू दॅट? म्हणजे काय, आय कॅन स्टार्ट सम अदर चॅप्टर ओव्हर देअर, सो साइड बाय साइड इट विल गो अहेड. मी ह्याच्यामध्ये आय डोंट वॉन्ट टू रश अहेड, कारण ऑर्गॅनिक केमिस्ट्री सच दॅट इफ यू डोंट फॉलो सगळं सगळं अनकम्फर्टेबल होतं मग पुढे. ते बेसच जर तुमचा असा हे राहिला ना डायसी, तर म्हणून मी स्लोली जाते. सो इज इट ओके दॅट यू वुड वॉन्ट अन एक्स्ट्रा लेक्चर, और हे जात आहे ते चालू राहू दे? बट देन आय विल नॉट बी एबल टू गो व्हेरी फास्ट. सो व्हॉट डू यू सजेस्ट?
मॅम यू गो विथ द सेम पेस. आय मीन कारण की कॉलेजमध्ये आता चाललंय ना ते जरा फास्ट फास्ट नेते.
हो,
तर ते
कळलं.
डिटेल मध्ये एक्सप्लेन नाही करत.
नाही, बरोबर आहे. मी डिटेलमध्ये करणार, कारण तुला 12वीला हा बेस आहे, त्यामुळे मला ते सगळं करायचं, म्हणून मी हायब्रिडायझेशन आता घेतलंय. पण मला आता एक सांग की संडेला मी घेतलं तर चालेल का लेक्चर तुम्हाला? म्हणजे मला टायमिंग साधारण
मला चालेल मॅम.
चालेल ना?
हो.
Okay, then we'll tell madam which is a time good for you, so that I can discuss with madam and try to have it on Sunday. So regular Monday, Friday lectures we can have this chapter हळूहळू जाऊ देत, आणि दुसरा एखादा चॅप्टर जो जरा सिंपल वाटतो तो मी करून टाकते. I think we have to do 3 chapters, but they're pretty long. This chapter is very long.
मॅम कुठचाही टाइम चालेल.
कोणताही चालेल तुला? Okay, fine. So then I'll discuss with madam and then we'll keep one. Yeah.
हा
Fine.
मॅम चालेल.
Okay, thank you so much. So let me continue. थोड़ा जरा घेते मी. Okay, now as you said it very correctly, the polar organic reactions are brought about by two types of reagent. Okay, depending upon their ability to accept or donate electrons from or to the substrate, reagents are classified as reagent, is which means something which is going to react with. Now we normally consider carbon as the species or the base. Anything which has the carbon compound, it is considered as the substrate, and then anything which is coming, now in this case ammonia, which is coming or which we are adding into the reaction, sulfuric acid, HCl, or some other cyano reagent, these are the reagents which you are adding, taking something as a base. But okay, fine, I want to carry out a reaction on propane, then my propane becomes a base, or propene, then propene becomes my substrate, and then anything which I'm going to add, say for example I want to do an addition reaction of propene. That is, I'm going to add the double bond, I'm going to add chlorine, or I'm going to add bromine. Then my bromine becomes a reagent. Now the polar organic reagents are reactions are brought about by two types of reagents. Now polar organic means normally which take place in a solution and which result in the formation of charged species. Charged species means your carbocation or carbonate. Depending upon the ability to accept or donate electrons from or to the substrate, reagents are classified as electrophiles, nucleophiles. Okay. Now these reagents which are going to come and how they are going to attack, what type of, at the beginning itself, how that reagent is going to be there. So it could be an electrophile. Now understand the term phile, hydrophilic. Hydrophilic, and that is the one which likes water. Okay, hydrophobic and hydrophilic. So hydrophobia म्हणजे आपण इफ यू म्हणजे तुला माहिती असेल तर हायड्रोफोबिया म्हणजे पाण्यापासून भीती वाटते. से रेबीज वगैरे झालेले असतात त्या व्यक्तीला दे आर हायड्रोफोबिक म्हणतात, म्हणजे त्यांना पाणी बघितलं. हा, सो दॅट्स
ह्याच्यामध्ये होतं
लास्ट इयर होता ना. सो हायड्रोफोबिक मीन्स दे हेट वॉटर, बट हायड्रोफिलिक मीन्स दे लाईक वॉटर. So that kind of so here also electrophiles, those which like electrons are called as electrophiles. Nucleophiles means nucleus is positively, normally it is considered, so there are no electrons, devoid of electrons, so nucleophile. Okay, so that is this. So the polar here they are classified as, the reagents are classified as electrophiles, means look at the E plus, it is shown as E plus. E plus manje it does not have E plus means this is this wants electrons, it is seeking electrons, electrophile. So this does not have it has less electrons and it wants to complete it octet. So it is going towards center which is having more electrons. Say for example, okay, I'll take that later on. Next is nucleophiles, that is that which has electrons with itself, but it is seeking for a positive charge center. But then you can understand nucleophile and so an electrophile can entertain a nucleophile and a nucleophile can entertain, म्हणजे ह्या दोघांमध्ये रिॲक्शन होऊ शकते. कारण इलेक्ट्रोफाईलला हव्यात इलेक्ट्रॉन्स आणि न्यूक्लिओफाईलला हवंय पॉझिटिव्ह सेंटर, कारण त्याच्याकडे इलेक्ट्रॉन्स आहे. सो either your substrate has to be an electrophile or your reagent has to be an electrophile. If your substrate is electrophile, then your reagent naturally is a nucleophile. And if your substrate is nucleophile, then your reagent is an electrophile. कळतंय तुला काय, what is reaction? म्हणजे आता A समजा माझा substrate आहे, तर A माझा पॉझिटिव्हली चार्ज आहे. सो दिस इज गोइंग टू बी अ इलेक्ट्रोफाईल, कारण त्याच्याकडे इलेक्ट्रॉन्स कमी आहेत. सो इट इज इन सर्च ऑफ द रिएजंट विच इज अ न्यूक्लिओफाईल. मग ह्याच्याकडे इलेक्ट्रॉन्स आहेत आणि सो दिस इज अ न्यूक्लिओफाईल आणि ह्या दोघांमध्ये रिॲक्शन होणार, बिकॉज this will give it and then you will get the product as AB. Okay, that is the octet is complete. Now look at this, there is no charge because the requirement of A for electrons is fulfilled by B. Are you following? Karta?
हो मॅम.
Okay, so आपण थोडंसं complete करू एवढं. Okay, let us see. So electrophiles meaning electron loving species accept electrons from the substrate. Thus electrophiles are electron seeking species. This is because they themselves are electron deficient, because म्हणून त्यांना आपण इकडे पॉझिटिव्ह दाखवलंय. For example, a positively charged ion such as BrCH3 or a neutral species having a vacant orbital such as AlCl3. These are few examples. Okay. For example, a positively charged ion such as Br, I think this is there, positively charged ion Br, but they should have given a better example. Okay, or CH3 or a neutral species having this actually is neutral species, but it can accept electron because it has got vacant orbitals. Now coming to vacant orbitals, म्हणजे त्याच्यामध्ये थोडं पुढे it has some orbitals which can readily, though it does not have any charge, positively charged, but it readily accepts the electron, so therefore it is an electrophile. Nucleophile is nucleus seeking species, give away electrons to the substrate. Now these are the ones which have electrons with them, they want to give it. This is because nucleophiles are electron rich species. For example, negatively charged species such as OH minus. See, OH minus, ह्यांच्यावरती direct charge, or even water can, neutral species such as water, it has got lone pair of electron. Here you can see lone pair of electron. Fine. So let me just complete this. एवढं करूया आपण, सो दॅट मग पुढच्या वेळेला मी पुन्हा रिव्हिजन घेईन. अ पॉलीएटॉमिक थोडंसं करते. अ पॉलीएटॉमिक इलेक्ट्रोफाईल हॅज अन इलेक्ट्रॉन डेफिशियंट ॲटम इन इट कॉल्ड ॲज इलेक्ट्रोफिलिक सेंटर. So that is, there are many atoms in this electrophile. Say for example, it is a long reaction. एक polymer किंवा असं काहीतरी मोठा molecule बनायचा आहे, a macromolecule बनायचा आहे. So it has many atoms, and it has electron deficient atom in it called the electrophilic center, while a polyatomic nucleophile has an electron rich atom in it which is called as a nucleophilic center. So the, if you look at the center, or if you look at any reaction, say for example now हे आपण मगाशी बघितलं CH plus, and then you have this is a polyatomic molecule, tertiary butyl molecule. What would you call it as? CH3. What is it? It is an electrophile or a nucleophile?
Electrophile.
It is an electrophile. And here you are, we are, sorry, forget it. And so this is a polyatomic, and this carbon is the electrophilic center. Okay, now coming to, say for example, plus OH minus. Okay, of course here, or let me, it's a group, it's just a single this. Now here this is there, this can happen, you can have, the reaction can go over here, and you can see that this has got the electron, so this is a nucleophilic molecule. But if you have similar large molecule with this negatively charged, then the atom on which that negative charge is, you can call it as nucleophilic center. For example, the electrophilic center of the electrophile AlCl3 is Al. If you remember, Magashi Pandmi arrow dakhotana, I was very specific in showing that arrow going towards carbon, because that would be the center. So always remember that whenever technically, if you have to be correct, you should be showing the arrows or the bonds to that particular element only. So in this case, I cannot show the negative charge. Is Al, because now Al has got 6 valence electron. If you look at it, though it is neutral, it has got 6 valence electron, and it has got a d orbital. So it has got an extra orbital, and then it can accept that electron in it. There is a possibility. The nucleophilic center of the nucleophile H2O is O. Now in this case, oxygen is having a lone pair of electrons. So oxygen is the nucleophile, that is, you talk about oxygen which has got 2 lone pairs of electron. Okay, let us next time we'll take this, so let us stop over here. So thank you very much, Sankalpa, and we will meet not this Sunday, we will meet next, let us March, not 28 February is the last, then March onwards we'll start going on Sundays. Is it okay? Yeah, thank you.
Thank you, ma'am. Bye.
Bye.